With just this glass of water, we can generate enough energy to sustain a person for 60 years. The process that enables this is nuclear fusion, which could solve our global energy crisis. So why aren't we using it now? Let's first understand how fusion works. Two light nuclei belonging to atoms of the same element fuse together, forming a single, heavier nucleus and releasing energy. But where does this energy come from?
Well, when nucleons come together to form a nucleus, the mass of the nucleus is less than the combined mass of the individual nucleons. The difference in mass is the binding energy of the nucleus. Similarly, in fusion, as the nucleons rearrange themselves, the product nucleus is lighter than the reacting nuclei and the extra mass is converted to heat and light energy. This conversion is explained by Einstein's famous equation, where m is the difference in mass or mc squared is the difference in binding energies. But here's the problem. Getting two nuclei to combine is tough. Both nuclei have protons, so they are positively charged. This means they repel each other. The repulsive force is called the Coulomb force or barrier. Luckily, there's an attractive force between all nucleons that opposes this, called the strong nuclear force, which is what makes them stick together in a nucleus. But for this force to outweigh the Coulomb force, the nucleons must be kept at very high pressures and temperatures above 10 million degrees Celsius. Why? Well, the strong nuclear force is developed when nucleons exchange particles called mesons. But this exchange only happens when the gap between them is less than the diameter of one nucleon. Getting this close to a proton is difficult because it's surrounded by an electrostatic repulsion barrier, an invisible circular boundary. Imagine the barrier to be the guarded walls of a fort. The neutron is an ally, so the guards allow it to enter the fort. It has no charge, so it easily gets past the barrier. But the proton is an enemy soldier. As it moves closer to the walls, the guards put up more shields and throw more spears at it. The repulsion gets stronger. The proton needs to be pushed past the barrier by increasing the temperature to speed it up and increasing the pressure to force the two protons closer together.
That's like creating a mini sun on Earth. But in 2022, there was a breakthrough. Scientists at the National Ignition Facility struck a hydrogen pellet with 2.05 megajoules of energy, and after fusion, it released 3 megajoules. This means that the energy increased by a factor of around 1.5. Now, many countries are coming together to make nuclear fusion a reality. Projects like the International Thermonuclear Experimental Reactor, or ITER, and the Spherical Tokamak for Energy Production, or STEP, are aiming to make our dreams of clean energy come true. If we crack the code on nuclear fusion, we could power the entire world with just a few glasses of water.